Hello friends, welcome to my channel. Let's have a look at today's daily challenge problem. Problem 223, rectangle area. In this video, we're going to give a detailed analysis of the problem. Actually, for this problem, the coding is sort of trivial, but the method of analysis is important. First, I'll read through the problem statement to digest the requirement, and then we share the algorithm or the analysis, and finally we do the coding. First, the statement. Given the coordinates of two rectilinear rectangles in a 2D plane, return the total area covered by the two rectangles. So the first rectangle is defined by the bottom left corner ax1, ay1, and top right corner ax2 and ay2. So similarly, we can define the second rectangle with A replaced by B, right? So here is one example. Let's look at example 1 only. So in this example, so we know that these two rectangles have an overlap. When we compute the covered area, we need to sum the two rectangle areas and then minus the overlap. So this is the point we need to notice. So here are the constraints on the coordinate components. So we will not go into details for that. So with that said, let's look at the analysis. So here, actually, for this problem, our method is the following. We're going to fix one as reference, and then consider the relative position of the other one with the fixed one. So here, what's important, as we mentioned, is the method of analysis or reduction of the problem. So the algorithm is as follows. So step 1, so we are going to fix rectangle 1 to be the left one. So this can be easily achieved to compare the first coordinate, right, in the bottom left corner. So if needed, we just need to switch the two rectangles to achieve this. Therefore, after step 1, we assume rectangle 1 is in the left. So step 2, so we need to consider the non-overlap cases. So this is actually very trivial. First, we notice that there are three possibilities, right? So first, rectangle 2 is V right? So in this case, the left x coordinate, that is bx1, is larger than or equal to the right coordinate of the first rectangle. That is bx1 is greater than or equal to ax2. So the second case is that the rectangle 2 is V above. In other words, the smaller y coordinate for rectangle 2, that is by1, is no less than the larger y coordinate for the first rectangle, that is ay2. So this is the second case. The third case is that the rectangle 2 is V below. In other words, the higher y coordinate for rectangle 2, that is by2, is below the smaller y coordinate for the rectangle 1, that is ay1. So this is the step 2. So in these cases, actually, we just need to sum the two rectangle areas, right? So step 3, so the overlap case. So the complement of the cases in step 2 is the overlap case, right? So in the overlap case, we just need to compute the overlap area, right? Once we can compute the overlap area, and then, so what we can do is to sum the two area of the rectangle, then minus the overlap, right, as here. So in order to compute the overlap, we need to compute the length, let's call it delta x, and the height, let's call it delta y. So delta x is very easy to compute because we already put the rectangle 1 to the left. So it's the minimum of the x coordinates of ax2 and bx2, then minus bx1, right? So this is the case. So actually with that done, so we can compute the height delta y. So for this, we consider two cases, and later we reduce the two cases into one. So first is by1 is greater than or equal to ay1. In other words, so the second rectangle bottom is inside the first rectangle, but the top of the second one can be inside the rectangle one or extend out the rectangle in the above. So in this case, delta y is the mean of the second coordinate, y coordinate of the two rectangles, that is by2, ay2, then minus by1, so the larger one between these two. And the second case is by1 is below ay1, right? So in this case, we need to use the mean of the second coordinate by2, ay2, then minus ay1, still the larger. So in this case, 3.1 and 3.2 can be reduced or combined to the formula delta y equals the mean of by2, ay2 minus the max of by1, ay1, right? So once we have delta x and delta y, then computing of the covered area is trivial, right? We just sum the area of the two rectangles, then minus delta x or delta y. So with that done, so actually we can write the code. So first, I'm going to compute the area of the two rectangles, and then we just check if there are overlap or not, right? So to compute the area sum, so it's very simple, right? So the area sum, so sum of areas. So this is nothing but ax2 minus ax1 times b, let's see, ay2 minus ay1, then plus the same thing, that is bx2 minus bx1 times by2 minus by1. So this is actually always fixed, right? So this is the case. So now what we want to do is that, so we want to check so if there are overlaps or not. So for this, I'm actually going to use this one. So I introduce two arrays. So ax1, so ay1, ax2, ay2, right? Rec1, rec2 is bx1, by1, bx2, by2, right? Then I want to first put rectangle 1 to the left. So now let me check. If ax1 is larger than bx1, then I just switch these two, rec2, rec1. So this way, we always make rectangle 1 in the left, right? So make sure rec1 is in the left. So we want to make use rec1 as a reference, right? So now let's check if the non-overlap cases, So this is actually very simple based on the three cases above. So this is that either the rec2 0. So rec2 is v right? So this is rec2. The x coordinate is larger than rec1. The larger x coordinate, right? This is one case. Or rec2 is v above, right? So it's greater than or equal to rec1, the larger x coordinate. Or rec2 is v below, that is rec2 3 is less than or equal to rec1 and 1. So in this case, so there's no overlap. We just need to return sum of areas. So this is the one case. All the other cases, so there will be overlap. So else, so the overlap will be computed using the delta x times delta y, right? So the delta x, let me introduce the delta x just for fixing the idea. Delta x equals mean rec1 the x coordinate, right? So rec2 the x coordinate, then minus rec2 the smaller coordinate. So this is for delta x. So now let me write down also for delta y. So that is mean the smaller of the upper coordinates, that is y coordinates, that is rec 1, 3, rec 2, 3. Then minus the max of these two coordinates, right? by1 and ay1. So the second coordinate, that is with index 1, that is rec 2 index 1 and rec 1 of index 1, right? So then the overlap is nothing but delta x times delta y. So we do not need actually to introduce this delta x or delta y and this overlap. But for the clarity, so we introduce these three intermediate variables. So in this case, so actually we can return sum of areas minus overlap, right? So this is the overall problem logic. So here let me make a remark. So here is overlap case. Actually case or cases, right? As you like. So with that done, so I guess we can do a check now. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases. So as we mentioned at the very beginning, so for this problem, so the coding is actually nothing. But I guess what's important is the method of analysis or method of reduction of the problem. So once you actually have this kind of principles to get the analysis, so you can solve quite a large number of problems when relative positions are involved. So with this side, I guess that's about it for this video. Thank you.